This is the first in a series of videos where we're going to be looking at the question of reliability, in particular the question of Cronbach's alpha, and we're going to examine what it is essentially. If you're interested in analysing personal traits such as compassion, selfishness, xenophobia or empathy, sometimes some people consider it convenient to have a numerical representative of this trait. For example, if you wanted to see how xenophobic people were, you would try to measure it, but the problem is it's a qualitative variable. So you'd want to use something like a Likert scale, which I'm going to show you now, where you can somehow transform a qualitative variable into a quantitative variable. For example, you can have a questionnaire where the person being interviewed is asked to rate on a scale of 1 to 5 their level of agreement or disagreement with a certain number of statements or items. For example, if we're taking xenophobia, we could put on items such as X1, I feel uncomfortable when foreigners are nearby. X2, I resent the fact that a foreigner might take my job. X3, all Muslims are terrorists. It's obvious that the more one agrees with those statements, the higher a score one is going to get. But there is a problem, which is obvious. That is, for example, X3, all Muslims are terrorists, is so extreme, it's very unlikely that most people, even xenophobic people, would agree with it. Because it's a simple fact that 23% of the world's population are in fact Muslims. So if they were all terrorists, then nobody else would be left. So we wouldn't be doing this, we wouldn't be having questionnaires on the subject anyway. So we have a problem here, which is, to what extent do the items represent the trait we're trying to analyze? Now, if we have a series of items which are very, very consistent internally, in other words, they correlate very well with each other, then we should be getting something like this, which is respondent number 1 agrees totally or very strongly with all of the statements or items. Therefore, this person gets a rating of 5 or score of 5 for each item. Respondent number 2 disagrees very strongly, therefore only getting a score of 1 on each item. So at the end of the row, we can see the sum up kxj will give you the score that the person finally gets. K here represents the number of items on the scale, or in other words, the number of items on the questionnaire. Now look at the two equations at the bottom, 1 and 2. This is basic statistics. If you sum up a constant, then it's the same thing as multiplying the constant by k. In fact, if you sum up a constant from 1 to k, then you can just multiply xj, the constant, by k. The second equation indicates another very simple statistical point, which is that the variance of kj, where k is a constant, is equal to k squared, which multiplies the variance of xj. Now, an important point to notice here is that the only variance in this scale, when we have perfect reliability, the only variance is between the respondents. There's no variance between the items themselves. I've just shown the first two equations here, so the third one is a logical extension of the first two. Remember, k is the number of items on the questionnaire. The numerator in equation 4 is the sum of the variances for each item, and the denominator is the variance of the summed items for each respondent. Now, equation number 4 is Cronbach's alpha, which is used very widely to measure reliability. Notice how we use equation 3 to change the denominator in equation 4 into that which appears in equation 5. Similarly, equation 1 is used to change the numerator in equation 4 to that which appears in equation 5. From there on, we can simplify, which brings us to alpha is equal to 1. But what does this all mean? Some respondents may be entirely consistent and others not so. The variance of the sum scores of the respondents does not show how much is inconsistent. So let's look at a concrete example. Here, each respondent has responded entirely consistently. So the mean scores for each item are the same, as are the variances for each item. But that is not enough to tell us that the responses are entirely consistent, as we could have a situation which we're going to show in the next slide. Here we can see that the means and the variances for each item are still the same. But inconsistencies in the variances of the respondents lead to a decrease in the variance of the sum scores, so that alpha is now almost 0. And in slide 8, we can see that the situation is even worse. We've got negative alpha, as the variance of the sum scores is almost the same as the sum of the variances of the items. In fact, it's actually lower. What is happening is that the individual respondents are getting more and more indistinguishable. The sums of their scores are getting tighter around the mean, hence the reduced variance.